Hello everyone. So in today's video and in the future videos we will see how to prepare for Google's programming interview. So the main important thing in the interview is to think out loudly. So in telephonic interview and even in face-to-face interview, you should convey to the interviewer what you are thinking, what is your thought process. So it has multiple advantages like one, the interviewer will know how you are approaching the problem. And the second benefit is that he may guide you towards the right solution if you are going in the wrong direction. So it's very important that you think out loudly. And whenever you get a problem like this, you don't straight away rush towards writing the code for it, but first arrive at some solution. So the difficulty level of this question is from easy to medium. So if on the scale of 1 to 10, I would give it a 6. So it's a candidate for telephonic interview as well as face-to-face interview. So now let's start towards the problem. So this problem says that you have to find a triplet, that is three numbers out of this array whose sum is 0. So for example, in this case we have 0, minus 2 and 2. So these three sum to 0. We also have this 4, 2 and minus 6. So these two are the only triplets in this case. So let's see how we can approach towards solving this problem. So when you are asked this question in the interview, it's very unlikely that you will straight away get the solution. So you may start by the easy solution, like you need three numbers, so you can run three loops. So you can take three loops, I starting from 0 to n minus 2, then j from 1 to n minus 1, or n minus 3, then n minus 2, and k from 0 to 2 to n minus 1. And so you will have one I, and for that I, take that I and find the two numbers whose sum is 0. So fix I, fix j, and iterate for all numbers from third number till last number. Then take the next j and again do the same for following numbers. So this is order n cube solution. So it's not a great solution, but it would be a good starting point during the interview. So the interviewer will himself ask, can you do better? So then you should move towards other solutions. So once you have this naive solution, you can move towards the better solution. So the other solution is that you can first sort this array. So this will be minus 6, minus 2, 0, 2, 4 and 7. So our aim is to do better than n cube. So sorting will take n log n time, and then here you have to look for all the triplets. So you can take three variables, one I. So this I index will start from here and go till third last, and then we will take another index variable which will go from second position till second last, and then we will name it L for left, and then I will take another variable which will start from third element and go till last, and we will call it R for right. So we are not allowed to repeat the numbers, like we cannot say 0 0 0 because 0 is only single time. So the three numbers has to be distinct. So one index start from first element till third last, then second to second last, and then third to last. So now let's fix the I. So initially I will be 6. So we have to find a value after I in this array, two numbers whose sum is minus 6. So our required value is minus 6. So what we will do, L is minus 2 and R is 7. So R will start from last number and L will start from immediately after I. And this array is sorted now. So if we sum L and R, we get 5 here. So our aim was to find, so first number is, so I is 0 in fact. Here this is array, then this ARI is minus 6. So we need plus 6. So here L is minus 2, R is 7. So we get 5. So which is less than 6. So our required value was 6, but it's less than 6. So L is the minimum number from the in the array after I, and R is the maximum number. So if we add these two and we get 5, but we want larger number. So this concludes that this minus 2 cannot be part of the triplet when minus 6 is there. So we had taken that minus 6 is the first number of triplet. Now we are looking for two other numbers. So minus 2 cannot be here, because if we take minus 2 and then the largest of this number is 7, but still adding 7 gives only 5. So even the maximum number fails to equal that number, it's less. So we have to increase L. So this minus 2 cannot be part of the triplet. So now L moves here. So since this value was less than 6, we will do L plus plus. Now L becomes 0 and R is still there, 7. So L plus R is now 7, which is more than 5. Now this L is 0 and we have fixed I. So this 7 cannot be part of the triplet when minus 6 is part of it, because we have ignored 2 in the previous step, and now we have to find two numbers from this 0 to 7. But if we take 0, then we cannot take 7, because it's more than 6. So we have to decrease the value. If we move L towards right, then the value will further increase. So we will instead decrease R. So we will do R minus minus. So now L is 0 and R is equal to 4. Now L plus R is 4, which is less than 6. So now with the same logic, we will now increase L plus plus. So L now becomes 2 and R becomes 4. So L plus R is now 6, which is equal to 6, our desired value. So when I is minus 6, we got one solution. So we got minus 6, then L is 2 and R is 4. So this is one solution. Now we will repeat the same thing with next I. So now one more thing, if it's equal to 6, then we will increase L and decrease R, because if L is here and R is here and their sum is 6, then if we increase R, their sum will be more than 6, and if we decrease R, their value will be less than 6. So we have to increase this and decrease this. So we will do L plus plus and R minus minus. So now L becomes 4. So L's value becomes 4 and R's value becomes 2. So they have crossed each other. So L has come here and R has come here. So in that case we will stop because we had started immediately after I and L was moving towards right and R was moving towards left, and when they crossed we have scanned all these numbers, so we will stop there and increment the value of I. So I now becomes 1, so ARI becomes -2. So let me write down the array again. So now I is here, and let's find the next pair of numbers. So L is here and R is here. So we want +2. So 0 plus 7 is equal to 7, which is more than 2. So we will do R minus minus. So now it becomes 0 and 4. Again more than 2. So again R minus minus. So now we will add 0 and 2 because now R comes here. So which is equal to 2. So we will print that value. So we have to print array I, array L and array of R. So ARI is -2 and L is 0 and R is +2. So this is second solution. So now L is here, R is here. So if we have to increase this and decrease R. So now they cross each other. So we stop and take new value of I. So now let's write it again. So now I is here. So our required value is 0 to find two numbers from here to here whose sum is 0. So L is here and R is here. But we can continue and we will ultimately not find any number because we have all the numbers strictly greater than 0. So there is no way that their sum will be equal to 0. So we can stop here and we will print just these two values, just two triplets, -624 and -202. So this is the same value that we had written earlier. So how we will write the code for this? So we can find 0 sum triplets. So it should take one array and the number of elements if you are writing in C++, otherwise you will not need this second parameter. So I will start from 0 to n-2. So we will leave last two numbers because I is supposed to be the first number of the triplet, and then required val is equal to minus of ARI. Now we have to find two numbers from I plus 1 to last element whose sum is this required value. So L is equal to I plus 1, R is equal to n minus 1, and while they not cross each other, so if they are more than required value, we will decrease the last index If they are less than required value, we will increase the L++. Else, the else will be there. That means that they are equal. Then in that case, we will print I, or ARI rather, element at index I, element at index L, and the value at index R. So we will print these triplets and then do L++ and also R minus minus. And this loop will terminate when they cross each other. Then it will pick the next value of I and do the same thing. So we will get these values. So let's write the code, running code in C++, and see what it prints. So let's start writing our function. So we will print these triplets. So its return type will be void, or you can put an additional return type to return the number of values it printed. So first we need to sort the array. So let's include the algorithms library. Algorithm. So it has an inbuilt sort function. So now it will sort the array. Now we need to run a loop from 0 so L is the first element after I, first index after I, and R is the last index after I. So the value at index I is ARI. So we want negative of that because we want their sum to be equal to 0. So if it's more than val, then we will do R minus minus. Otherwise L++, and finally they are equal. So we will print the triplet. So after printing, we will change both the indices, because if we change just one index, then they will not be equal anymore. Now this should take care of everything, I think, because when L and R cross, they will exit this loop and take the next value of I. So let's run this on our example. So this is the same example that we had taken. So we can call this and pass AR and this number of elements in AR. Now let's run it. So it correctly prints -624, whose sum is 0, and -202, whose sum is also 0. So this is how we would solve this problem, and this is a good starting point for building your algorithmic thinking. So I will be uploading more problem statements, and also I will also be explaining the solution and the running code for the same. So stay tuned for my future videos, and all the best for your Google interviews.